Coming up, a working M3 engine that we then naturally take apart. But is it any good?
0.0.
Hello and welcome back to part 4 of Project Frankfurt. In the previous episode, we removed the blown up engine and discovered a Bluetooth crankshaft. The main bearing spun at 233,000 kilometers, rendering that block an instant coffee table. This means we need a complete replacement engine, so say hello to this 2009 Alpine White E93 M3 with 165,000 kilometers. I bought this donor M3 from a very nice subscriber named Boki from Ireland. Big thanks to him for reaching out and for selling me this car. While it might look good at first glance, it actually has structural damage. It was either hit on the right side or it hit something enormous that the front right strut tower buckled and cracked, which is why the wheel is not sitting straight. This and the fact that it's right-hand drive makes it a perfect donor car for Project Frankfurt.
Started. Very good. Last time I tried, the starter was dead. A bit rattly, but the S65 is alive. Sounds good. Very quiet. So weird being on the wrong side of the car.
Given that we are dropping the engine, we are going to completely take it apart and rebuild it, as the S65 engine not only has issues with the rod bearings, but also with the main bearings wearing out prematurely. We're going to talk more about this later in the video.
Rattled from the bottom. I was told it has an exhaust leak. We shall see.
The car has a stamped service book and a bunch of invoices, so it'll be interesting to see the wear and tear and if the main bearings are indeed due for replacement.
I can rev the snot out of it because I'm about to rebuild this engine. Sounds good, doesn't it? Here we go. First, we're gonna do the service position with the L stick. (2016). Very nasty. Into the bin. Cabin air filters are positively nasty as well. Quite bent. Look how low this engine actually sits. Race car, strut tower, the engine way below it. Now I'm gonna drain the oil and coolant. Oh wow, that was really tight. The oil filter. The oil looks clean. No metal shavings. Coolant. We have coolant. Dundas style plug. There we go. Let that drain. Nice blue coolant. Hello, Lev. Oh, that is not a stock bolt. There you go. That is ridiculous. Someone stripped the threads here and they used a wrong bolt. Do the second one here. This is a stock bolt, drain bolt. I don't need to, but I want to remove the electric fan now, just to have a bit more space in the front. Plus, it takes like 3 seconds. Positive cable. The battery is disconnected. The wiring harness. That's the wiring harness disconnected. Another coolant line. More coolant. Thankfully, the AC system on this car is empty. I already checked that. It's just residual air. And here as well, there's nothing in the system. So we are safe to remove AC lines. It's one line disconnected, and the second one. Disconnect the power steering line, this one, which is quick disconnect. Oil cooler lines. Fuel line. And a vacuum line. There we go. And then 2 coolant lines, I believe. Memory serves me right. This one here on the bottom. What's a little coolant among friends, right? That one is disconnected. And then one more that goes through the firewall into the heater core. There you go. And I believe that's everything disconnected on the top. We have some sort of tricked out wheel bolts. This will give you an average 5 to 7 horsepower. Depends on the color, of course, and how you torque them. And I'm pretty sure these are not made in China and that they are not poor quality. And this tire is mounted the wrong way around, but that's okay. The rotors are shot. The right tire is good. Only a tiny bit of wire is sticking out. You know, not a big deal. The reinforcement plate. Jeez, that's rusty. It snapped. Is this what it's like to work on a UK car? Every bolt snaps. 2 for 2. The transmission is leaking. The exhaust, now I'm gonna see if I can separate the back box here. Make it a bit easier to remove. Now the big guy. Yeah, that snapped. Perfect. There we go. Now I'm gonna remove this support here. This is specific to the convertible. Now watch the exhaust drop on my head. Is this heavy? It's not too bad. Yeah, this is much easier than removing the entire section, which is what I've done with Project Frankfurt. Ah, that one snapped. It's good. O2 sensors. All right. This is a lot easier if you split the exhaust. Center shaft bearing appears good, and so does the flex joint, the Guibo. Right. The prop shaft is out. We're going to be dropping the engine together with the subframe. So we need to disconnect various connectors here, like the headlight leveling sensor. There you go. Disconnect the little arm just in case. And now the steering column. There we go. Disconnected. Now I'm gonna remove and hang the caliper on the side. First we need to disconnect the various sensors. Need to remove the sway bar link as well so I can get the brake hose on the other side. Okay, that's the caliper removed and out of the way. All right, now I'm gonna copy paste on the other side. Gonna disconnect these connectors here. All right, shifter linkage. Excellent. Oil cooler lines. The fluid looks really good. Need to disconnect the line that goes from the reservoir to power steering pump, which is this one here. Oh no! There you go. The struts are coming down with the subframe and the engine. Wow, the nut is actually cracked. Can't get the socket on it. Look at that. This is from the impact. The nut broke. This entire thing here is mangled. And with that, we're ready to lower the drivetrain. Perfect. So in the front of the subframe, middle of the subframe, engine, and the transmission. Now I'm going to support the car in the back because we're removing a significant amount of weight from the front. So by the diff should do the trick. Now we can start removing subframe bolts. Oh wow. Transmission cross member. Gingerly. Alright, the shock's free. Now I'm gonna go up top and just make sure I disconnected everything. Everything around the transmission is disconnected. Did we disconnect everything? Yep. The ground cable, we got that. We are clear for landing. Roger, roger. Ooh, that alternator looks brand new. I guess at this point it is a tradition to ride this like a horse, though this one isn't blown up. I think I prefer the manual one. It's much more comfortable. This one has a cooler here. Not very comfortable to sit on. But other than that, it feels exactly the same. All right, enough goofing around. Graciously. By the way, if I'm not producing enough manly sounds, that's because I have a cold. Sort of sick. Don't feel that well, but we shall soldier on. Say hello to magnificent Project Raleigh. All right, man, all right. All right, let's first get rid of the wiring harness. Transmission wiring. The ignition coils are worth a fortune now. You can only get them from the dealer and they're stupidly expensive. And that's the engine wiring harness out. Engine mount. Get the apple picker. Coolant line here that I need to open. Power steering line. There we go. You are free. I think that's everything. Divorced. All right, now you can join the manual transmission here. Now I need to remove the flywheel. I lock the crank in the front. Coolant leak here from the plug, and maybe a rear main seal a little bit. Yet another engine stand. The previous one that had mechanism there was complete and utter garbage, so I sent it back. All right, I'm gonna assemble this and then we're gonna continue. This engine stand is not good either. Look at this. So this is just gonna tilt all the way in. Garbage. Oh my God. This engine stand sucks as well. Look how tilted the engine is all the way to the front. It's doing the same thing as the fish stand that I returned. But this is the same model as the old one, and the old one doesn't do this. This one is like disappointed again. Now I need to return this garbage as well and buy the exact same model as the old one. Why didn't I do that in the first place? Plenty of grease here. I'm gonna call it a day here. I'm really, really tired and I'm not feeling well, so maybe we pick this up tomorrow, maybe not. Alrighty, I'm feeling marginally better. So let's take this thing apart. Power steering line. Is that seized? That won't budge. Throttle actuator linkage disconnected. Oh wow! These are rebuilt units. That is awesome. Look at that. This is from the guy from the UK, Jason something. I got the rebuild kit for the E60 M5 over there from him as well. This is brilliant. So these are totally reusable. This one as well? Yep, both of them. Look, there's a date stamp here as well, May of 2022. So these are pretty fresh. It's great news. Bad starter. This is a port injected engine, so the intake valves are squeaky clean. You can see that they're ported from the factory. This one is seized on as well. Original pump. Feels fine. Snap, this is fairly fresh as well. Original Vallejo unit from 2020. It's perfect. No need to replace it. That being said, I did buy a new one. Now I want to do a leak down test and see if this engine is actually healthy. Precious coils. Not particularly great. First we need to make sure that the piston is a TDC, top dead center. That is TDC. That is one nice looking cylinder. Okay, cylinder number one is a TDC. Has a leak down tester. Connect the air. That's really good. Cylinder number one, 2%. That's excellent. Another perfect cylinder. 2% again. 3%, cylinder number four. Just finished doing the leak down test and we have a very healthy engine on our hands. I was reading the gauge incorrectly before. Cylinder number one, 4% loss, 5, 4, and then 6 in cylinder number 4, and then bank 2, 4, 4, 4, and then the last one, cylinder number 8, is 9%. This is all still within spec, which means that the valves are sealing properly, that the piston rings are good, so great news overall. Let's continue with the teardown. Now I want to remove the oil filter housing, but in order to get to this bolt here, I need to remove the vibration damper first. Now the crank is locked. These are one-time use stretch bolts. So this one is not as clean as the old one, huh? I mean, it's not bad, it's golden, but this is what happens when the oil change interval is too long. You get this varnish all over the engine. These caps are okay. So the old engine with more miles was cleaner on the inside, but it went boom boom. Ooh, we have rust on the camshafts on the sides here. You can see that some of the camshaft lobes have surface rust on them, so the cams need a good polish at the very minimum. But that's fine because we're not going to use stock camshafts. We are going to go with Schrick cams. OEM plus, baby. Same story here. Surface rust on the cam lobes. Now we're going to remove the Vanos gears and the camshafts. Get the engine at TDC. There we go. Timing tool. Now we need to slightly rotate the intake cam so this can sit flush. Like that. Same with the exhaust side. And then here, the holes don't line up. So this tool isn't, it's not good. Gonna order the original one. It's probably gonna be very expensive, but worth it. Special tool to align these gears on the exhaust Vanos unit. Now we need to use M5 screw that's not longer than 10 millimeters and put it in this hole here. This is going to keep the exhaust Vanos gear in place because, as I said, it has springs inside. Good. Vanos unit bolts, they are counterclockwise thread. So to undo them, we're gonna do that clockwise. There we go. Bag and tag. Now we need to release the timing chain tensioner. All right, copy paste for bank 2. Time to remove the camshafts. Mint condition. Now we're going to slowly release the screws from inside to out. I'm not explaining a lot in this episode because I've already done this with the blown up engine, but I'm just taking everything apart. All of these caps are labeled and I know exactly where they need to go once we start putting this engine back together. The camshafts are in good condition. The surface rust, that's just from sitting, and that can be easily cleaned up with a nice fine Scotch-Brite. Now I'm going to remove the lifters. Time to remove the oil pan. Yeah. This is great. All right. That's not too bad. Not a lot of sludge, bit of varnish, but nothing too terrible. Before I remove the oil suction pump, I wanted to see what the factory spec is for the gear backlash here. I don't think this engine was ever taken apart, so this should be the factory spec. According to the repair manual, it should be from 0.06 to 0.08 millimeters. So I have my little dial gauge thing set up here. And now if I rock the gear back and forth, we should get a reading for the gear backlash, which is 0.08. And that's within factory spec. And when the time comes to put the engine back together, I'm going to set it up exactly like that. Now we're going to remove the cylinder heads. First we're going to do bank 1, and we need to remove the head bolts from outside to in. So we're going to start from 10 and then end up at 1. First of all, head gasket, perfect condition, not blown, but we already knew that. Ooh! Cylinders are mint, at least these two here that I can see. Man, good engine, really good engine. Bank 2. There we go. Oh, yes! It's unbelievable. They're like brand new. Look at this beefy timing chain guide. It's in perfect condition. There is some wear or grooves from the timing chain, which is absolutely normal, but look at that. Compare this to the S62 or M62 or whatever older previous generation of BMW models, and then this one. This is proper stuff. This is gonna last pretty much forever. Because this is one solid piece of composite plastic, while on S62 and M62, N62 as well, it's just a small piece of plastic here on the front, and then it's metal on the back, and it's always that thin plastic that breaks in the front. Love this. Here's the guide up close. You see grooves from the timing chain, but in perfect condition. Even on the old engine with more miles, 145,000 miles, they looked perfect. Why didn't they do this from the get-go on all of the engines? Now I'm going to mark the pistons. Quick vacuum, wanted to make sure we're not pushing any dirt, sand, and whatever once we start removing the pistons. And also fogging oil for men. Help the pistons slide out easier. Overkill, but the cylinders look so good, I don't want to put a single mark in them. Time to remove the rod bearings, and if memory serves me right, this engine never had the rod bearing service done. I don't have records for that, although I didn't go through all of them, but let's see. These are stock rod bolts. Yep, we have wear, not a ton, but this is the lower one. You can see here that it says 088/089. So these are original factory BMW bearings that they put into S65 and S85 from 2007 to mid-2010, and these have lead in them, and they're very soft on the crank. And later they were replaced with 702/703 bearings, and those have aluminum, copper, and tin in them, so they are much harder on the crank when they wear. Definitely original BMW rod bearings, never replaced on this engine. I'm gonna put a piece of tape on the con rod, that way I'm sure it's not going to scratch the cylinders when I pull out the piston. Rod journal in perfect condition. No scratches or scoring marks or anything. Now I'm gonna remove the rest of them. That's all of the pistons removed, and the crankshaft is in great condition. All of the rod journals look great. These are original factory rod bearings, never replaced, and as you can see, they're all worn out, especially the top ones. They see the most abuse. Some of them are showing signs of copper, like this one on the edge there, that one as well, and this one here. The top ones, none of them are down to copper, which is good. This one maybe ever so slightly, but again, not terrible. I've seen far worse than this, and this is definitely the right time to replace them. Rod bearings, unfortunately, they are a service item on this engine, S65 engine, as well as the S85. We are not going to go with stock bearings. We are going to use BE bearings in the new engine. Well, rebuilt engine. The pistons, they're actually pretty carboned up. Had trouble removing some of them because of the carbon. They were sort of stuck. Visually, they look good. Some wear on the skirts, some marks here and there. And this is typically from carbon getting stuck in between the piston and the cylinder. These are not scoring marks, so visually they're definitely reusable. They need to be cleaned, and we need new piston rings. But we are going to measure them a bit later. And we might actually go with brand new pistons as well. Now we can remove the intermediate piece and the gear wheel. That's what the repair manual calls it. Now we're going to remove the bed plate. First, according to the repair manual, we need to remove the fitting screws, and we got to do that in the sequence from 1 to 10. These are the M9 fitting screws. And now the M11 bolts, also from 1 to 10. Ooh, they stink! It's like, ugh. Now 3 million torque screws. There is a specific sequence for them as well.
Let's talk about the main bearings and why they wear far more than they should on the S65 V8 engine, while on the S85 V10 engine, from which S65 is derived, there are no issues or reported main bearing failures. On the previous video, someone left a comment that because S65 has double row timing chains, the strong tension from the chains is pulling on the crank at high RPM and putting a high load on the first upper main bearing, which is the one that typically always fails and has the most wear. Then take into account that S85 engine has single row timing chains, and this suddenly makes sense. Another theory I've come across is the difference in bearing material. In mid-2010, EU regulations mandated the removal of lead in automotive bearings, so BMW switched from lead-based bearings to tin-based bearings at that point. Lead-based bearings are softer and easier on the crank, while tin-based ones are harder and more prone to spinning. Now, I've done a lot of research on this topic and talked to reputable shops in Germany as well as the US, and through that research I found that predominantly LCI models from 2011 and up see the most main bearing failures. In comparison, E60 M5 with the S85 ended production by 2011 and therefore didn't see tin-based bearings, which again doesn't have issues with the main bearings, only the rod bearings. So one can say that this makes sense as well. The bottom line is, while both S85 and S65 have issues with rod bearings due to the tight clearance, the main bearings on the S65 are wearing very poorly as well. This is why you'll often see people changing rod bearings and shortly after experiencing main bearing failure as they wear too. The failure rate of the main bearings on the S65 is certainly not as common as with rod bearings, but it is something to look out for, especially on higher mileage engines.
Off to the table we go. Hello, main bearings. Now I need to carefully lift out the crankshaft, and this is pretty heavy. Ooh. Look at that, one-piece crankshaft. And look at the main bearings. The main bearings, aka the main reason why I took this engine apart, because as you already know by now, this engine not only has issues with rod bearings, but it also has issues with main bearings. And here we have number one upper main bearing, and you can see that it has quite a lot of wear. This is how it should look like. Nice initial whitish coating. And then if we come to the bed plate, number one, lower main bearing, barely anywhere, as you can see. So the theory that the timing chain is pulling up on the crank and putting pressure on number one upper main bearing is looking pretty good here, because yeah, look at the wear there, and then the bottom one looks nearly new. The rest of them look good. And then on the bed plate, the rest of the lower ones, not looking good. Quite a lot of wear. These are the old main bearings from the LCI engine, from the blown up engine, and I wanted to do a quick comparison because pre-LCI main bearings are made from lead and these are made from tin, and even though they're different materials, they look pretty similar, wouldn't you agree? Quite a lot of wear on all of them. Here, obviously number one was wiped out, number two is bad because the crank broke, but here pre-LCI is marginally better, but about the same. So this one is definitely better than that one. That being said, these have 105,000 miles and these have 145,000 miles. So the theory that the main bearings are wearing out because they're made of different material, it's not looking very good right now. Let's inspect the cylinder bores. Look at this. The cylinders are mint. No scoring marks anywhere. What a score this engine is. We have a block that's in very good condition. The crank is good. The bed plate is good. The heads are good. Really happy with everything. 105,000 miles. Mainly the bearings are worn out. The rod bearings and the main bearings. But everything else looks great. But given that this is a high performance engine that uses 10W60 oil, it is what it is. It all depends how you use the car as well. If you abuse it right from the get-go when you start the car and it's cold, yeah, it's gonna wear. Now I'm gonna measure all of the pistons. I have my E92 tool here, very good quality. I actually invested in all of the tools that I need for an engine rebuild because this is not going to be the last engine that I'm going to rebuild. So we are measuring the pistons at the piston skirt here, a bit above the bottom edge, so right about there. So brand new piston should measure 91.99 millimeters. So exactly like a brand new piston, 91.99. There you can see the readout, 91.99. This is piston number 2. Same. The results are in, and the pistons are, well, basically brand new, no wear. All of them are exactly the same and safe to be reused. They just need to be thoroughly cleaned and carbon removed. Piston rings, we can probably reuse them as well, although I definitely want brand new piston rings just to be on the safe side. The thing is, they're not available from Male. That's the OE supplier. You can only buy these piston rings from the dealer directly, and they cost 883 euro for the set of 8 piston rings, which is outrageous. Super expensive. If you buy them directly from Male, it's usually 30 to 35 euros for a set. Much more cheaper. I did find one company in Germany. They offer S65 B40 piston rings aftermarket. I don't know if they make them, but supposedly they are of very high quality and they cost 400 euros, which is not too bad. But I'm also thinking maybe brand new pistons from Male Motorsport. They're forged pistons, they come with piston rings and new wrist pins as well. So I need to do some thinking and decide if I want brand new pistons or, I don't know, we find an alternative and just go with brand new piston rings instead. Now we're gonna check the crankshaft and measure the journals and check for any wear and if it's out of round. I've actually already done this, but my microphone died, so there was no sound. But anyway, I have yet another micrometer from E92, and I already know that the crankshaft is going to be good because we don't have any spun bearings. The engine doesn't have million kilometers to have any significant wear. So the main bearing journal, which are these 5 here, the dimensions for that 59.9694 to 59.9821 millimeters. And we're going to measure here and then 90 degrees offset. And this one is slightly above 59.97. So that's within spec. And then if I measure here, I am getting the exact same reading, which means that the journal is within spec and it's not out of round. I've done the same thing with the rest of the main journals and they're all absolutely perfect. When it comes to the rod journals, it's the same deal. We're measuring here and then here as well. And then I'm gonna do it for each journal or each rod bearing. Actually, I've already done this, but let me just quickly demonstrate. So here we have 51.98. So that's within spec, bang on the money. And then exact same thing here, which means that the rod journals are not out of round and they're within spec. I can't move my camera to show you this, but let me just drag it out real quick. Here you can see that it says 51.98. So the crankshaft is mint. Just need to clean it, nothing else. Now the main bearings. From BMW you get 3 flavors of main bearings that have different clearances, and they are yellow, green, and violet. On the crankshaft as well as on the block, it'll be stamped which main bearings this engine uses, and we have all green on the crankshaft and all green on the block, which makes it rather convenient. But I don't want to use stock bearings because, as you can see, they wear pretty heavily, so King Racing makes main bearings for this engine, and I ordered a set of performance bearings. These are racing bearings, whatever, the Black Series or something like that. So very, very strong, good main bearings. But we can't just slap them in and say, okay, that'll work, because from King you only get one size bearing, and from the dealer you get 3 different sizes. So what I have here is one green main bearing. And the easiest way to see if the King Racing bearings will work is to measure them. I've already done this, but I'm gonna do it again so I can show this to you as well. So I have this tiny micrometer here to measure the main bearing. Here you can see that the brand new original green main bearing is 2.49697, close to 2.5 millimeters. And now we're gonna measure the King bearing, and this one is a perfect match. Here's the measurement for the King Racing bearing, and you can see that it's showing pretty much the exact same thing as with the original one, 2.496 millimeters, which is what it states on their website. This means that we can use King Racing bearings in this engine. They're also a hell of a lot cheaper than the original ones. These are around 160 euro. And original ones are close to 400, 375, something like that. And these should be more stronger and durable than the original stock bearings. I also measured the rest of these King Racing bearings, and they're all the same spec. So that's as far as the main bearings go. We have a solution there. For the rod bearings, you're going with BE bearings and ARP rod bolts. Next, we are going to measure the cylinder bores, and for that we are going to use this bore gauge from 103k-Mile. And I already put extension on it, 92 millimeters, and I already zeroed it out, but let me show you how we're gonna do that. So here's another Japanese micrometer, which I've calibrated, and now I set it to 92 millimeters. And when I put my bore gauge in there, and if I rock gauge up and down, I need to find the 0 position and then turn the dial on the top and match it with that. I've already done that, and that's right on the 0 there. So the bore gauge is zeroed out. And now we're ready to measure the cylinders. The bores, that is. So this is the truss side and this is the non-truss side. As this is a used block that's been in service, we are bound to see more wear on the truss side. As the crankshaft is doing its thing, it's pulling the piston up and down. The piston is naturally rocking in the cylinder bore and therefore putting more pressure on the truss side and therefore creating more wear. We are looking to see if the cylinder bores are out of round or if they're tapered. And we are going to measure at 3 places, just below the ridge of the piston rings, then middle of the bore, and then towards the bottom. And then same for the non-truss side. First things first, if you are dealing with an alusil block, which stands for aluminum silicon, be careful how you use this tool. On the 103k-Mile bore gauge, these tips, they are carbide, which means they're harder than the cylinder bores. And if you're too quick and too aggressive with the tool, the tip is going to leave marks in the cylinder. And those marks, they're purely cosmetical. They won't affect anything, but to me that looks ugly and unprofessional. So the way I do it is I put a little bit of oil in the cylinders, and then I'm compressing the tool and putting it where it needs to go, and then I'm gently rocking it back and forth, and that way I'm not leaving any marks in the cylinder bores. If you go quickly top to bottom like that, super quick, you are definitely going to leave some marks. So keep that in mind. So let's start with the non-trussed side. That's 0.01. I don't know if you can see that on the camera. So I'm gonna go write that down. Then the middle, that's 0.015, between 0.01 and 0.02. The truss side, I don't know if you're gonna be able to see, it's really tricky to do this while holding the camera, but truss side, top, we have 0.035. In the middle, we have 0.025. And then the bottom, we have 0.025. Now I'm going to continue and measure the rest of the cylinders, and then I'm going to show you the final results. 0.01, 0.01, 0.015. Bank 2, 0.01. 35, okay. 0.03. And the last cylinder, cylinder number 8. 0.02. The results are in, and we have good news. If you were to buy a brand new S65 block, the size of the cylinder bore would be 92.00 millimeters or 92.02 millimeters. This is taken from TIS BMW repair manual. TIS also says the permitted outer round of the cylinder bore is 0.01 millimeter, and permitted conicity or taper of the cylinder bore is 0.01 millimeter. But that is for a brand new block, brand new engine. It doesn't say anything for a used one. The only thing it says, engine operated, permissible total wear tolerance between piston and cylinder, aka piston to wall clearance, 0.15 millimeters, which is actually quite a lot, and we are well within that spec. If we look at the sheet here, you can see that the truss side definitely has more wear than the non-truss side. We have on cylinder number 1, 92.03 at the top, and then middle 0.025, and then on the non-truss side we have 0.02, 0.015, and then cylinder number 2, 92.035 at the top, and then on the bottom we have 0.025, and then on the non-truss side we have 92.01. So that will be the difference of 0.025 millimeters, and that cylinder is slightly out of round. But this is totally acceptable for a used engine. This block has 168,000 kilometers. These results are actually pretty impressive for a such high revving engine with that many kilometers. So as you can see, we have pretty much the same results all over the place. There's no major wear of the cylinder bores, and we can definitely work with this block. It's definitely usable, and that makes me happy. Here's the game plan. I want to drive Project Frankfurt this summer, at least before the winter, which means I have to avoid the machine shops. My initial plan was to send out the heads to Topmar in Poland, have them refurbish them completely, do the multi-angle valve job, but I've decided not to do that because remember Project Marseille, E91 850i, the heads are still not back. It's been, I don't know, maybe over 6 months now. It's not their fault. We had massive problems with shipping, with parts supply, then holidays, just delay after delay, and it's taking forever to get those heads back, and I can't do anything with the car in the meantime. So I don't want the same thing to happen to Project Frankfurt. As the heads pass the leak down test, we are simply going to lap the valves, clean them, replace the valve stem seals, then clean the heads entirely and put them back together. The crankshaft is perfect, doesn't need anything, just needs to be cleaned before the reassembly. The pistons, we are going to go with higher compression forged Male Motorsport pistons. The only problem is they're currently out of stock everywhere. Should be available again mid-August, so hopefully I can get my hands on them and then I can measure them and just make sure that the piston to valve clearance is correct. We're also going to go with Trick cams. I've been talking to them and they're going to give me a really nice discount on the camshafts. valve springs and retainers. So that's going to give us a bit more HP as the shriek cams are a bit more aggressive and sportier. So great news there. The block, I was planning to do nothing with it, just to clean it and reassemble it as it is, as everything is great and within spec. But I've been talking to Peter from Party Racing from the United States, and he gave me a bit more info about AluSeal and honing the AluSeal surface. If you remember Project Chicago, when I was rebuilding the second engine, I took that block to a nearby specialist in AluSeal, a machine shop, and they told me if they were to hone the block, they're going to remove from 0.02 to 0.03 millimeters. That's way too much, and we can't do that because it would increase piston to valve clearance, so I never ended up doing that with that machine shop. But Peter told me that if you're just going to etch the surface, in other words, expose more silicone in the cylinder bores, it's not going to remove any material, or whatever material is going to be removed, it's negligible. Then I ended up talking to Herman from H2 Motors. They have a workshop near Cologne. They're just doing BMWs, and turns out they have Sonnen machines, products, and tools. Sonnen is a company from the United States, and they make all of the stuff to hone AluSeal blocks. And he told me the same thing. If you just want to etch the surface to expose more silicone fingers, it's not going to remove any material. And he told me, bring the block over, we'll get that done for you in a few hours, not few months. So we are going to be doing that in the next episode. It's going to be all about prep work, prepping the engine for the rebuild, the block, the heads, the pistons, the crankshaft, all of the bearings. And we're also going to take apart both of the oil pumps, clean them, make sure they're good to go. Basically everything that's related to the engine, just prep everything for reassembly. So in the following episode, the episode after that one, we can just go from start to finish, reassemble the entire thing, the entire engine. So I'm really looking forward to that. I'm really excited. I love how this engine is put together. It's super interesting with the bed plate. It is a racing engine, man. The heads are ported from the factory. The headers are beautiful. I actually got ceramic coated headers from a really nice subscriber as a gift, so that's gonna go on. It's gonna be fabulous, man. Once we're done with that car, it's gonna be beautiful. Oh, I almost forgot the piste resistance. Evolve Automotive, Imran from the UK, he's going to be sending me carbon fiber intakes and airbox for the intake system. So that engine is gonna sound nuts. I mean, the S85 in my Project Rally and the E60 M5 over there, that thing sounds crazy, but can't wait to hear the S65 with the full carbon fiber plenum, microfiber plenum, whatever. So I hope that you're as excited as I am about this project. I can't sleep at night. I'm just thinking constantly how I'm gonna put this thing back together because it's such satisfying work. So thank you so much for watching. If you enjoyed the episode, please consider subscribing and liking the video. I would really appreciate that, and I'll see you in the next one, which is probably gonna be on the E36, the one owned by the Princess. Need to fix it and then get it out of here because I have another car coming. Surprise, surprise. Ciao!